Hey guys, so Unit 4 is going to be about what's called momentum. And our target today, we want to be able to calculate the momentum of objects, right? So in this video, let's go ahead and let's talk about what is momentum, and let's talk about how do we calculate momentum. Momentum is a pretty, kind of simple concept. You can think about momentum in a couple of different ways. You can think about it, maybe say momentum is how hard would it be to stop an object, right? Think about a baseball, right? You think of in a professional baseball game, the pitcher, he throws the ball, and what does he throw the ball, like 90 miles an hour, right? And you see the catcher stops the ball with one hand. Okay. Now think, instead of a baseball, what if it was, a train moving 90 miles an hour? Would the catcher be able to stop it with one hand? Obviously not, right? So, even though the baseball and the train might be moving the same speed, there's something about them that's different that makes the baseball much easier to stop than the train. And that's the idea of momentum. If you think about the baseball and the train, obviously the train has much more mass. And so, because it has more mass, it's got more momentum, and they're going the same speed. So that momentum is kind of the idea that we're getting at here. You can think of it as how hard would it be to stop the object. You could also think about, sometimes you might say momentum is how much oomph is in something's motion, right? If you have a baseball and a train both at 90 miles an hour, that train's got a lot more oomph in its motion, right? So, you can think about it as how hard would it be to stop the object, how much oomph is in its motion, right? Momentum, we use the symbol P for momentum, lowercase p. And for many years, students asked me, why do we use P? Why don't we use M? Well, I can tell you why we don't use M is because M is for mass, and we can't use M for both. We can only use it for one thing, so we use it for mass. And for a long time, I didn't know why we use P. And so one year I looked it up, and apparently a few centuries ago, people didn't use the word momentum. They called it impetus, which comes from a Latin word petere or something like that. So that's where your P comes from. We use lowercase p for momentum, not uppercase. Uppercase P is power. We use lowercase p for momentum. Momentum is the mass of the object times its velocity. Okay, so it's mass times velocity. So if you think about the units, mass is in kilograms and velocity is in meters per second. So our units for momentum are going to be kilogram meter per second, kgm/s, kilogram meter per second. So that's the important equation there. Momentum, P, equals mass times velocity, mv. So let's go ahead and let's take a look at some examples of how to use this equation to solve some problems. Okay, I got two examples here that we're going to take a look at. The first example, it says calculate the momentum of a 4.0 kilogram object moving 12.0 meters per second to the east. So what I'm going to do, just like I always start my problems, I'm going to write down what do I know and what did they ask me for. So I see in there the number 4.0 kilograms, and kilograms, that tells me this is a mass. So I'm going to write down m equals 4.0 kilograms. I see 12.0 meters per second, and meters per second tells me that's a velocity. So I'm going to write down v equals 12.0 meters per second. And then, of course, the question asked me, calculate the momentum. So I'm looking for a momentum. I'm looking for P. So P equals question mark. That's what we're looking for. So then what I'm going to do is I'm going to use the equation we just talked about, P equals mv, and I'm going to put the numbers in there. So m is 4.0 and v is 12.0. So now I have P equals 4.0 times 12.0. Then I'll go ahead and I'll multiply that. 4 times 12 is 48. And I need two significant figures in my answer. If you look at the numbers, 4.0 had two significant figures, 12.0 had three significant figures, and so I go with the least. So I go with two significant figures. So my answer there is going to be 48. And then the units, I need the units for momentum, and momentum is in kilogram meters per second, like we just talked a minute ago. So P equals 48 kilogram meters per second. Okay, the second example here, it says a 5.0 kilogram object has a momentum of 25.0 kilogram meters per second what is its velocity? So just like all my problems, I'm going to start by listing what they told me and what I want to find. So 5.0 kilograms, I know that's a mass, so I'm going to put m equals 5.0 kilograms. 25.0 kilogram meter per second, it tells me that's a momentum, and it's kilogram meter per second, so I know that's momentum. So I'm going to put P equals 25.0 kilogram meter per second. And the question asked me, what's the velocity? So that's what I'm looking for. So I'm going to put V equals, question mark. That's what I'm looking for. So I'll use our equation there, P equals mv. I know the P is 25.0, and I know the M is 5.0, so I have 25.0 equals 5.0 times V. And then to solve that, I'm just going to divide both sides of the equation by that 5.0. You see it's there with the V, so I'm going to divide by the 5.0. So 25 divided by 5 is 5, and in my answer, I need two significant figures. So 25.0 had 3, and 5.0 had 2, so I go with the less. So I need two significant figures. So it'll be 5.0. And since the velocity, that'll be in meters per second. Okay, so there's a little bit about momentum, how we use the equation P equals mv to solve some problems. In our next lessons, we will learn about the impulse momentum theorem and the conservation of momentum. So hopefully that helps us be able to calculate the momentum of objects. So until next time, we'll see you later.